It's my pleasure to once again introduce two colleagues of mine, Matthias and Birk, who have done what and of course I'm biased, think quite relevant research in the area of big data environments. Yes, thanks for being here.
My pleasure.
No other choice.
Yeah. Yeah, I mean, also, one of the last times Anna was chairing me, I went horribly over time. So let's see how this will go today. Thank you. Okay, Birk and I will give a presentation about big data environments today. I hope it will be interesting after lunch while everyone is in the food coma. I especially saved my dessert for later, so I won't have the sugar and won't fall into that like a big hole of sleepiness after lunch. So let's see what we can tell you. First of all, Birk and I, we both work for ERNW.
Yeah, I'm Birk Hall. I'm a security researcher at ERNW, and actually I wanted to cut out mainly exploit developers. It was just some show off. But after Matthias put in mainly managing too much, it was funny and we let it stay there.
Yes, I have to pass off the technical work to the younger guys and take care of the more boring stuff of managing and organizing stuff. However, I think I could contribute some formal aspects of a security evaluation to the big data environment area. So, yeah, I'm pretty sure you've heard about this in the meantime, so I'm not going into detail about the ERNW landscape and who we work for. I think most of you have heard of this. So, what are we going to talk about today? Actually, it's quite interesting. I mean, it's always chic to reference to the keynote of the conference, so I'm just going to do that. When Rodrigo was talking this morning about like securing the overall platform and stuff like that and working on like very basic problems, and I thought, oh well, and we have this talk about big data environments, which is another hype topic. But then again, he had this slide where he said we need to implement like state-of-the-art protection mechanisms. And he also like mentioned one that we evaluated for the big data context. So I was quite happy that I could at least partially reference the keynote in here, and I will do that later shamelessly. So, who of you are running big data environments in their IT environment? Some like shameful hands showing. Okay, I would say that's about like 20% of the people here. I think in another year or two we would have like way more hands up. So this is definitely still an emerging topic. So we'll give you a short overview what big data is, what Hadoop is in particular, which is the prevalent big data solution out there that everybody is using in one way or the other. And afterwards we will show you, okay, how can you attack those environments, and then of course, how can you also protect your data in the data lake, which is another buzzword in that area. And of course, we will have some nice conclusions that will hopefully help you. So, what is big data? Big data is, of course, like still a big buzzword. Usually in a workshop, I would ask whether you have a definition. After I did like workshops on cloud computing for 4 years, there were finally some good definitions on the topic. I'm not sure whether that would already be true for big data. And we have also some nice quotes that will probably explain that a little bit better. We will give you a short example how it does work and what the typical ecosystem of a big data landscape looks like. So you get actually an idea of the involved components, and based on this idea, we will see what threats we have to deal with in those environments. So, what is Hadoop actually? This will be the main part of the introduction. However, before we do that, I found some nice quotes that I needed to use because I liked them really when I was doing some background research. So, before doing this background research, I wasn't aware that there's something like a Gartner hype cycle that they actually publish every year. So I think it's bad enough that that exists. But however, there's like the hype cycle, and then there's the peak of inflated expectations, and after that there's the plateau of productivity. And somehow they cut out big data of this because they said, okay, big data is already everywhere. In all of our lives, in all the big cloud environments, they are all doing that. So big data is already there, we don't need it in the hype cycle anymore. So this somewhat holds true for the big cloud environments, Facebook, Google, Amazon. Of course, they are all doing like big data, whatever that means. We will talk about that again. But for most of the traditional IT environments out there, it's more like this. we need a big data cluster in 3 months. And then the IT department is stuck with building one. However, the IT department is then asking questions, okay, what are we going to do with it so we can actually design it in a secure way? However, then this quote comes into play that I also really liked. So basically everyone thinks we need to build those big data environments, but the use cases are not clear yet. So I think this is all built up. The IT departments have to build environments, and then we will see how we can use them. So I think this is still pretty much the state that we have out there. So what we are trying to do is to give some guidance for the IT departments out there that have to build a big data environment and that want to know about the risks associated with it. So, a little bit of history about Hadoop actually. Hadoop is like the main big data implementation, and its predecessor was actually created by Google in order to index the whole World Wide Web. They also released it first in 2007, and since then we continue to go on to release 2.6.4, and Hadoop is like one term, so there's some core Hadoop services that we have, but in the meantime it's like a huge ecosystem of components that we need. And since it's such a huge ecosystem, there are also like two main enterprise distributions out there, Cloudera and Hortonworks, which basically make money of packaging this solution for you. All those components that are comprised into all those Hadoop, in this Hadoop environments, it's just a horrible job to set up, so nobody wants to do that. Everybody would need a full-time equivalent that is working for 1 year just on setting up the environment. We tried it and then said, okay, no, that's not a good use of time. We're also just going to use one of those distributions. So if you're doing big data, you most likely will end up with one of those distributions because you just don't want to compile that from source. So before we show you the ecosystem and all the components, we will give you a short idea why big data is relevant. So let's say you want to select the average age of your contacts and order that by age, the average age of your contacts by number. In a SQL statement, you would have like a rather small statement that you can use to select this data. However, when you think, okay, how would I need to calculate that, which data sets I would need, if you just think about it, this becomes like complex really fast. So the database management system is taking care of that for you. It's abstracting a lot of this complexity in the background. So you can write simple and nice statements. However, I mean, relational databases have some difficulties when they need to scale out. So that's a problem of them. So this is one of the big advantages of big data. You basically have always two working steps. You have a mapping step and you have a reduce step. And this is like the basic algorithmic framework behind the big data environment, the map-reduce idea. So, as we can see on those two slides, we basically have the mapper function and we have the reducer function. We're not going to go into detail what this is actually doing, just to give you an idea that you actually have to do some more coding if you want to do the same calculation that we had in this short SQL statement, if you want to do this in a big data environment. However, the big advantage is that basically there's also a framework around that that allows you to have data locally on your system, which is not a big deal. Of course, your database management system has that as well. But if we look at this number, we have 1,100 batches of data, 1 million data sets in each. So we have 1.1 billion data sets that we need to process. This is something that sometimes difficult to do for relational databases. So Hadoop spreads this job out on multiple cluster nodes. We will go into the naming details later. And it will also distribute the different jobs that are all doing like one batch of data on that one server that has a certain data set locally on the hard drive so that no network access is possible. So this is also a performance thing in order to scale out such jobs horizontally. So this is the basic advantage of big data environments.
Since we didn't have a lot of clues, or the companies, we asked them what the data is used for, or the cluster rather. I give some use cases for it, because a lot of companies already use it. And one of it, you can add to the cluster artificial intelligence. By this means, you can predict upcoming flaws, whatever data you stream in. Just for example, production machines. You can predict if someone probably fails in the future, like if there's some differences between the outcome of it. A lot of companies will use it that way. And you can analyze behavior of machines, like if the quality of the product increases or decreases. This is something as well which can be done. One thing which as well is pretty cool, you can display the data in real time. By this means, when you have your production line, you always want to see the data in real time on your cluster, and you want to compute it that way. And one thing that scares me a lot is analyzing people. And Facebook does that. I mean, a lot of people actually use Facebook, and you probably know that whatever you put into Facebook, it will be used for their own purposes. And there's a particular thing I heard about it. It's like, I guess when you send a message to another person, you can guess that this will be computed in any way. But as well, if you just writing a message and then deleting it again because you had another thought, Facebook gonna compute this as well. And they're gonna see if there's a relation into it. So if you have a special relation to the other person, or maybe your statement was politically incorrect or something, they can analyze it in the end. And insurance company gonna use it a lot more in the future. Just for example, in Italy, there's already the telemetry module in the cars, which analyze your driving behavior. And this cluster means a lot of money for those companies. Well, we picked Hortonworks, and just to give a brief overview about it, this is like the ecosystem. This is the official picture from their site. You can see there's tons of different services running just with this one cluster. And they have cool names. I don't know how they come up with Scoop or something.
And that's basically all the different names is a different open source project. So even though it's an enterprise distribution, it's still open source projects.
Exactly. And if you have Cloudera, for example, they may have different names, but the basic idea behind it is the same. And since we picked Hortonworks, this is something like the management UI. Maybe some of you guys run this cluster and you already saw this, but this is probably used to keep track of the complete cluster and the resources used and whatever's done on it.
Don't worry too much about the text. We just wanted to include some screenshots and give you an idea what the different components are actually doing.
Yeah, and there's some base commands or base structures used. It's the jobs, and MapReduce is actually doing the job, for example. It delivers the jobs to the different nodes, but we get more in detail later. Just to give a brief overview, this is like just a web UI to keep track on it. It's not something you can build on there. And the resource manager, as well, if you have a big cluster, you have to keep track of the resources. Like if some hard disk of one node is filled up, it won't get any new data. And people are using Hue. It's some sort of third party. It's an own company which produced Hue, and it's basically just a wrapper for all the functionality of it. Basically, before that you had to use Hadoop with the command line a lot, and this makes it really comfortable for people to use it in a corporate environment. And you can push everything you want into it, but I have a demo of it later if you can't read it exactly.
There's actually even more components where you don't even need to write code anymore. You can like click your different jobs by using some templates and some data flow visualization. So you don't even need to program. There's also a web interface for clicking your job together.
Yeah. And the last thing I just briefly show is the Ranger. It's as well from Hortonworks. The equivalent would be Sentry on Cloudera. And it's based for the policies on it. If you have logging or user and groups, this can be handled through Ranger. And we will look later at the cluster as well with policies on it, just to keep you that there's something for access list policies.
Just already as a heads up, when you read about Hadoop security anywhere, the first thing that it comes up in any like article or book or anything is like, oh, there's Ranger on this other equivalent, and you can define access control lists anywhere there. So this is not what we will focus on, but we will also like refine that focus later a little bit.
Yeah, and before I further advance, we will always talk about two different definitions. And one is the default cluster. Default, what I mean when you pull it from the internet, from the distributor, and you don't enable anything. It's just like the pure setup. This is the default cluster, and it basically has not a lot of security features, and we call it no security at all. And there's the secure cluster. Hadoop brings a lot of tools to secure everything, and with everything enabled, we're going to call it secure cluster in the end. Just the two demos, one is on the default cluster and one is on the secure cluster, just to summarize it.
It refers to the features, not to the actual state of being.
Yeah. And to get a bit more technical, there's a file system Hadoop uses, and you can imagine it like a little overlay over the Linux system. And it's needed because the data is always distributed on different nodes, so they had to implement their own file system, and this is called the Hadoop Distributed File System, in short HDFS. And basically what it does, you have a client and you want to put data onto your cluster. You have a lot of data and you're gonna do a request. This request will be sent to the nodes, to the name node. The name node is eventually in the end responsible for all the stuff done on the cluster and the file system. And let's keep tracks of the file.
That's like a big registry that knows which data is located on which node. It is also actually a single point of failure in your Hadoop environment. So if this thing goes down, your Hadoop environment does not work anymore.
Basically, you often have secondary name nodes or third name nodes. You can click them as many as you want. And when this request is at the scheduler, they're going to tell the client to split the data into blocks. They're going to always call it block, and it's hard splitted. Like they have the default sizes, 64 megabyte or 128, and if you have a big enough format, it will be splitted at 64 megabyte. And then it will be distributed to the different nodes. Then what Hadoop does for you, it will replicate all these blocks. So Hadoop has some sort of a self-healing system. The self-healing system is responsible to always have at least 3 of the same blocks on the server. And they will, with the algorithm, it's completely random, they will distribute these blocks. So there's always at least 3 on the system, and the name node in the end will keep track of it. This is because when a node falls out due to hardware failures, other nodes can replicate their blocks and send it again across the whole environment. This is some sort of a RAID system, but I really don't recommend it as a whole backup. As I talked about the overlay of the Linux file system, when I grabbed it on the single node, this is basically what it looks like. It's just like in some default folder and with a lot of sub-tiers. And you can see all the data on it are only blocks. They have the nodes in the end have no idea what data they actually store, what is the name, or is there any correlation with it. They simply have only blocks and some metadata. And this is later one of the problems we're gonna tell you about. And to give a bit of an overview about the network on Hadoop, there's a lot of network stuff going around, and they have their own RPC protocol. It's obviously over TCP, and this is used for the heartbeat. Like whenever a node drops out, or he doesn't send a heartbeat, and the name node knows about it. So this is used for it, and the resource monitoring. So the nodes always send their hard disk capacity or anything else to the service. And HTTP is mainly used for managing the jobs. Like you can pull the request, oh, I have to do this, I have to do this. And for the web application and later to put the services on it. This is just some brief overview about the RPC. I was trying to find a good dissector in Wireshark, but basically either the project got cancelled or is not fully implemented. Wireshark has a bit of the HDFS, but not everything in total.
There's also not a really good protocol definition about this RPC protocol out there. So.
Yeah, it's kind of tough to read. And the first thing when I looked at the cluster, I net started the services because I wanted to know what's going on there. And it's tons of Java. There's like, it's just a little part of it, and I grabbed it, And it was like 62 different processes listening or talking to other ports. And this is Java. Java everywhere on these single clusters. It's immense. And to basically, the whole idea behind this is with the jobs. You can, if you want to compress data or compute data, you're going to make jobs. And jobs are done via jar files, which is basically Java in some sort of a zip file with some informations in it. And this will be as well, again, sent to the job scheduler.
And this is just really Java with some additional libraries that in a special format in order to be processed in the Hadoop environment.
The additional libraries are basically just to tell Java how to handle the HDFS file system. And then there's a mapper function, which Matthias already talked about, where you map the different blocks or the data to different nodes. And the nodes in the end are called reducers. And when you execute such a jar file on the nodes, they call it container. And this is because they want to kill a container if the code is purely bad written or crashes at some time. So they can always kill it with some signals. And when it is set container, it's basically not really a container. It's a set UID binary which overlays its own process with the Java jar file. So
we should get Evil Sergey to do that, so we have a better name for that, now that I think about it.
And jobs, again, Java, they kind of look like this. This is just, I hope you can read it a bit, but it's just a simple word count example. When you put like a library on it, it will count the words. And this is the reducer function which actually count the words in general and put it back to the cluster so you can get some results onto it. And I call it actually code execution as a service if you want to implement it into your cloud system. This is how you should call it. And as an attacker perspective, when I first looked at it, it's code execution as a service. I think that's easy, right?
And this is also the point where we need to think about this whole big data environment. Okay, but what are the relevant threats here that we need to take care of? So we got a slight overview of all the different services that are involved. We see there's a lot of daemons running that are communicating over some protocols. But basically, it's just another very big distributed application. However, there's one big difference in this application. We have code execution as a service. This is the one big difference. I mean, we're not gonna talk about how you secure your Java applications. This is basically how you treat any application or any complex application in your enterprise IT environment. Really, the big difference that we have is that you submit jobs that are executed as code on the systems. So this is the one big difference that we have here. And this, of course, can result in unauthorized access to cluster data, for example, via a breakout of this job. It's not as easy as it sounds. We will have a look at that later, but it's possible. Of course, one of those nodes can also be remotely compromised, but that's just a traditional vulnerability that would exist in a Java application. All those daemons that we saw, they are just normal applications. This is nothing that we're going to talk about here because this is known stuff. This is not new and not specific to big data environments. And then, of course, data access can also happen via eavesdropping. This is also not too special. We're going to cover it a little bit because it's closely related to secure mode or Hadoop security. So we're going to cover that a little bit. However, what's also interesting, besides unauthorized data access, is when you can execute code, you might also abuse those resources to, for example, crack passwords or do Bitcoin mining. Not sure whether there's any proof of concept for Bitcoin mining out there or how fast it would be. Probably not that fast. But for password cracking, think about the word count example. You have like a mapping where you distribute a huge word list to the different nodes, and then you iterate through those. So this is like a perfect password cracking environment too. So what we call this is resource abuse. This is something that we need to take into account, especially if we're offering this as a service. It also depends a little bit on the perception of your service. If you're hosting this service internally, only for like other colleagues from your work environment, you might have a different trust relationship with them. However, if it's like a very, very large corporate environment, only hosting to users and maybe some business partners, this might leave a sufficiently big attack surface. For example, also, if you would compute or crunch any salary-related data in that cluster, then you also want to make sure that nobody can access your data, even from the same company. And then, of course, in the end, it's a service like any other service, so you want to keep it available so you can actually use it in your environment. So another relevant threat is the denial of service of the cluster environment. This can happen by slowing down the overall cluster, by like just having a huge amount of jobs out there, or just perform a DDoS attack against the master service or name nodes. If you recall that picture that we had earlier, usually that's not only 5 nodes that are standing there. Those are like dozens or hundreds of data nodes that are sitting there. And as we said, the master nodes or the name nodes, they are basically like the single points of failure. If you have the capability to spawn jobs that can reach them or access them on the network, and you have like 100 of nodes that have to attack like 5 or 6 other nodes, that's a pretty easy denial of service situation or attack that you can carry out here. So, to sum this up, there's a lot of like traditional application security in there. We will talk about that later when we talk about protecting the cluster, but the really big difference that we are facing is this code execution as a service. This is the big difference. And Birk will tell you more about that.
That basically was in the end my job. It was like just dropped to me and gonna have a look at it. And
thought you enjoyed it.
I enjoyed it a lot. Setting up the cluster was, anyway. There was in the documentation some sort shell command executor. I mean, I couldn't be luckier because it said that whatever I put into this
next time you write the documents. Next time you write the documents.
I will do. Basically what it does when you put stuff into this command, everything will be put into the shell and executed. It was like, yeah, okay. That's easy. I don't have to do much. One problem I told you about was the thing that the name node can kill the jobs. And this basically happened to me. Whenever I tried to just make a file on the system, perfectly fine, everything worked. But as soon as I tried to spawn the process and it tried to reconnect to me, it suddenly said I allocate too much resources and go and be destroyed. But there's one thing like Hadoop when I said about the streaming stuff. Like whenever you want to stream data to your cluster, you have an open, some sort of open connection always running, and this is the streaming library.
This is also maybe interesting to talk a little bit about. We said earlier that basically all the data is local on the nodes, and this is one of the big advantages of Hadoop, that all the data is processed locally, so we have no network transfer, no big latency, and all that stuff. So how does that streaming fit in there? So of course everyone wanted to do big data, but somehow realized, oh, we can't get the big data into that environment, so we just need to stream it in there over the network. Which is an interesting approach for a system which huge advantage was the data locality. It probably makes sense. Also, the whole system was built around being like a big key value store. What did people do? Oh yeah, we're going to build like a relational database framework around that so we can do our usual SQL queries in there. So there's basically all the typical enterprise software in the meantime is out there and built on top of that. There's an in-memory SQL database, I think Spark, all that other stuff. So basically people thought, oh yeah, Hadoop is the thing, we need to do it. Let's build all our traditional stuff on top of that. So here we go with streaming.
Yeah, basically what the streaming library does, you can put files into it, you can call it mapper and reducer, and it can be any arbitrary file. So the cool thing is I could do Python. I finally was relieved from Java, no offense, I just don't like it. And this is basically what it does. This is the same, again, word count example from Java, I just copied it, I didn't care. And this is the mapper function. So whatever data I put in, I could like do a real huge directory and it will be processed and sent all to the name nodes which could take care of my code. So then you might think the reducer function, it should handle some sort of the code in the end, but no, it's just a simple reverse shell and no one cares what the data does and I don't have to return anything. It's just simply a script and it executed and I can stream data. It won't be killed at all. And one thing that happened to me particularly, since there's a lot of different nodes behind a cluster, and when you think, okay, I'm gonna do this right, I do multi-listener, so every connection can come to me, and I send that the reverse shells to always reconnect when it didn't make it. So I got DDoSed by the cluster with my own arbitrary
Basically by
payload.
himself.
Yeah, by himself. So we had to kill the job manually, and it was kind of embarrassing. Anyway, now this is demo time.
Okay, while Birk is setting this up, so what we're going to demonstrate is this big difference that we've been talking about, that you have code execution as a service. When you read about Hadoop or big data online, this is what everyone is writing about. Oh yeah, you can execute code by design. And we were like, okay, but what does it mean? What can we do with it? When we can submit jobs, what's the impact? What are we going to do after? And nobody was writing after that, about that. So we decided, okay, we definitely need to have a closer look at that in order to be able to provide some reliable information. What is possible when you execute jobs in which configuration too? So I think there are like two big contributions that we can make here, like show you the relevant difference in IT security or in securing this cluster, so that is the code execution, and that we can also show you if you can submit jobs, you can do this, this, and this. And this is what we will show you now.
Well, basically, I have the huge browser I showed you before. I hope everyone can read it. I will make it later a bit bigger. And this one is with the user Matthias Luft. And he has some really important data into it.
As always.
Yeah, which is basically this text. Just keep it in mind. We will use it later.
Looks my notes.
Yeah, that's my notes. And it's me as an attacker perspective to see. It's a different profile. And when I try to access his directory and I try to access the important data, I get blown out. This is pretty bad as an attacker perspective because I really particularly want to know.
Can you zoom in a little bit?
Yeah, sure. This is what you get when you try it there. But as an attacker, what I can do, I can actually execute jobs. And to just show you, it doesn't mean that the guy has to be logged in and has a bad intention. It can be also like he wants to do a job, and he loaded some libraries out of the internet and anywhere, and it can contain bad code since it's code execution as a service. I guess all of you code with Stack Overflow, and this is how an attacker can use this. And basically, here we have an attacker system. I'm going to put it a bit into the middle, which listens on a local port. And I have to switch to mine. And we have a job designer. And this is my little job, which this is the mapper function, this is the reducer function, and we have some input and some output there. You always have to change it, just keep in mind. And there's the mapper.py file, which has just the word count, and the reducer function with my reverse shell. And let's hope this works. When I submit the job, it's pretty cool. And just to see a bit of the logs, the job will start. I hope you can see this. No, it's too far. This will just try to execute, do the mapper function. It can take a long time to actually do this. And on the attacker perspective, I hope that doesn't fail now, we just wait for the shell in the end. This
kind of the big topic of live demos, right? Waiting for the shell.
Waiting for the shell. Depends on, yeah, here we go.
Wait a second. Wait. I mean,
well, this is not the whole problem, since we know that's code execution as a service. Everyone guessed this is gonna be easy. One thing you have to see, like the idea here is not my own, my own user. This is just something that on the default cluster Hadoop gives you, which in the end means I can access every data I want on the system. And just to, I need some, yeah, I need this one. I hope I can do this. Fuck. Oh
Don't
gosh,
say
I
that
got
on
killed.
camera.
I got killed, as always. I have to do this again.
As you see, everybody thought, oh yeah, code execution as a service, trivial enough, but it's actually not that easy. There's like a lot of issues that you have to work around. You're still somewhat in a Hadoop environment.
Yeah, and I just accidentally pressed the brake, which killed myself right now, and I have to wait again. I hope this is fast. So, just to show you a bit, this is.
At least we see it's working reliably.
Yeah.
Not only one time.
That's very important. This is actually the config file of it for the streaming job. Not really important. Let's hope the shell comes back. And what I basically want to show you that with this sort of a backdoor, here we go. Hadoop, data, I think it's otherwise, HDFS, data. There's the CD current. And now I have to find this one. Hope I don't. Yeah. And this is the file which Hadoop. I will tell you later how to get this file in example. But as an attacker perspective, I would just simply dump the whole system. It's just like to remember the stuff. And this is what Matthias put in his own pocket. And this is some sort of authentication bypass on a default cluster.
So basically, can you do a directory listing in this whole directory?
Yep. I hope there's 3.
Yeah, I mean, you get the idea. There's like a lot of blocks in there. So basically, we could have just dumped everything, and the data would have been somewhere in there, so we would have been able to access it. The other way is just more convenient for you to show now. What's also relevant, this is the cluster in the default configuration without any enabled security features.
Yeah, well, then we continue with the slides and I have to set up the next demo.
Perfect. Okay, so that was the first demo. So we saw code execution is actually possible, and the relevant information or takeaway here is that the jobs in the default configuration are performed under a default user account, which is also used to process and store the whole data, which is not too surprising. I mean, when the jobs are executed, they need to somehow access the HDFS, which is done via RPC. However, it is not really separated from a user account perspective. The whole system is also like designed to be very close to the Linux environment. So if we would look at HDFS ACLs, it's basically pretty much the access control bits that are used in Unix environments. So it's very close to that. And the relevant takeaway is in a default cluster, you can actually execute code. It's possible. It's not too difficult. I mean, we had to spend quite a while on that, but people can do it. And then you are able to access the data from the whole cluster. Another thing that is relevant, we only have a system with one node here, which is already resource hungry enough for one notebook computer. However, if you have like multiple nodes, you just start multiple jobs in order to dump the data from all jobs. So the big question here is, how do we secure such an environment where the capability to execute code is somewhat intrinsic and required? I was also, second keynote I get to reference, Ben also had this quote in there, which was funny for us to see. So how are we going to approach this? So we have a longer list of recommended controls for Hadoop environments that we're going to discuss here. We're not going to discuss all of them. I don't think that I need to tell this audience that you need to patch your systems. At least I hope I don't. Some people are laughing. Maybe you need to tell that your users or your IT department, but I'm not going to tell you. And then I'm also not going to tell you that you should perform a penetration test of the services that you want to use in your environment. A short note on those two points together. Hadoop has a certain vulnerability footprint in the past. There have been some nasty vulnerabilities, but like over the last 3 years, the whole ecosystem had about 8 vulnerabilities, 3 of them with like a relevant impact, like an authentication bypass and stuff like that. In addition, there is no publicly available security assessment report or anything. No pen test report, no publicly available research that states, oh, we like did a security analysis of this daemon or this daemon. So there's nothing out there. We're definitely going to look into that in the future. We also looked into some of the interfaces at the moment, but not into too much detail. So we can't make a solid statement about the security posture of the different daemons out there, or the different components, or even the web interfaces. Don't think we need to get started on that. Okay, so let's talk a little bit about the other ones. So the most relevant control in a Hadoop cluster, which is probably not too much of a surprise, is that you need to enable the secure mode or use Hadoop security. It's just 2 terms for the same idea. If you enable this thing, you basically Kerberos all the things, and that helps you to enable authentication, transport encryption, and least privilege in the cluster. That reads great, right? But it actually helps you. So the easy things first. Basically, Kerberos is used to provide authentication between the different services that you have in your Hadoop environment, and also to enable transport encryption between those services. There are some very few exceptions that we will publish in a while when we compiled something of like some design considerations for big data environments, but the majority of the services is covered by secure mode. So the more relevant thing from our perspective, especially when it comes to this code execution as a service, is that every user and job gets an individual user ID assigned. So what we saw earlier, we had 2 different user accounts in the web front end, right? mluft and bkhauer. However, the jobs that they executed were run under the same Linux user ID. So this changes here. Basically, everything that you have in the web front end is then also transported to the Linux cluster. So if the job gets executed, you run under your own user ID, and you cannot access the block data that is stored there by default. So this is an incredibly relevant control that you need to implement if you want to operate this in an enterprise environment. So I don't think that we need to talk about the encryption of network traffic. This is another easy one. Make sure you have secure mode enabled and that you have HTTPS enabled for your web interfaces. This is the relevant distinction here. There are some Hadoop services, which is RPC, and some Hadoop web services. Those are covered by secure mode. And everything else, you basically need to enable HTTPS on the web interface, but this is also not big data specific. Relevant is it's possible for all of them. So it's not like we have some crappy legacy service that you can enable encryption on. So the next thing we looked into was basically when we saw, okay, we can't really prohibit this code execution thing because it's kind of the design. It's the whole idea of the big data environment. So we can't disable or harden away the possibility to execute code on the hosts. So we thought, okay, maybe if we can prevent it, maybe we can detect it and react to a job breakout. So we thought, what might be typical characteristics of a job that is performing a breakout? So we thought, okay, they probably have like extensive network connectivity. As we saw this here, we had to have some sort of like connect back shell or data exfiltration if you want to get data out of the environment. Then, of course, it would also be interesting to see, okay, is there any non-HDFS file system access? So in your job, you usually use the HDFS library to access data. If you do this on the regular Linux system, that might also be an interesting indicator that you want to look into. And then, of course, you have a long runtime on load because it probably takes you a while to exfiltrate all the data from the cluster. Problem is, when you think about jobs that process big data amounts, at least 2 of those also apply to those jobs. I think it's kind of the idea of big data jobs that they have extensive network activity and they have a long runtime and load. But basically what you can do here is like do traditional network monitoring for network traffic that leaves the environment. This is something that might be interesting. But other than that, the problem is job breakouts just look like regular jobs, at least from what we could derive in our environment. We would need some more live data from live environments. which we don't have at the moment. And when it comes to non-HDFS file system access, this is just nothing that can be locked by the Hadoop environment, because at that moment, you're already outside of the Hadoop environment in the traditional Linux system. So that's something you would need to monitor with default OS controls. So basically, probably a lot of effort with unclear success. However, the monitoring thing is something we want to look into more in the future to see whether we can identify something that allows us to identify job breakouts. So, in order to motivate that a little bit more, we have another demo here, which shows the same thing in a secure cluster, just to give you the whole impression that we actually have different.
Okay.
Yeah.
I hope it's readable. This is again Matthias Luft. This is the same setup, just on a secure cluster. And
we're not using the web interface this time, just because it's faster.
And he has again some really secure data on his own profile. And on the other side, this is I'm logged in there. And when I try to access this, I get kicked out. The same thing as before. But what it leaves me, again, I can be again an attacker. Same procedure as before. And one thing I gotta show you is like how to find the data, where it's put on the data. It's something like this, which is a deep-rated comment, and you can see this is what's its name. That's how I found it before. On in which nodes it relies. I'm gonna need it later for showing you again the important data. And well, as an attacker, I can still do the same as before, just to need another output directory. This is the same function on the command line as I did with you. Basically, completely the same. And this time we can see a lot more. It takes the security tokens from Kerberos and it authenticates with each other, and then it's trying to run the job. This can again take a while, since we will see when the mapping function starts. This is when it starts. I hope the listener runs. Yep.
I mean, we're not going to give you like advice on how to use big data environments, but there's a certain overhead involved with those big data systems. So unless you really have really big data, it's questionable whether the overhead would be worth the effort of running a big data environment.
And there's again the shell. But this time, I'm Bill Kauer, and my ID is intensely high. So when I try to access the same thing as before, I cannot access it because the permissions are higher than my actual UID. And this is something good you actually should implement on the server.
However, we still have basically access to the Linux server on the command line. And this is like some faked step of local exploitation that we're doing here. As soon as you have a local privilege escalation in your cluster OS, we have the same problem again. I mean, this was not an actual exploit here, just to illustrate the problem that we have here. As soon as you have privilege escalation in your cluster environment, we can still access all the data. And this again is something that can't really completely prohibited or like hardened away. So you need to think about what you want to do here.
Exactly. This is
let Birk finish.
This is the same thing again. When you have high privileges, you can get the important data as well. This just shows you why you need to harden in the end the nodes. This is where some measures will come now from Matthias.
Yeah, well, the measures are actually quite short. Make sure that your node operating systems are properly hardened. There's unfortunately not much more that we can recommend. I'm pretty sure you have some like Linux OS hardening guides in your environment. One particular point is maybe also make sure that your Kerberos keytab files are secured. If that is not the case, you also have some very nice vector of privilege escalation there. But other than that, try to harden your data nodes as much as possible. The nice thing is they don't need to have special functionality. try to deploy them in an automated way. There are tools out there in the Hadoop environment that basically prepare the cluster for you, so you don't have to anything to do about that. Use this functionality in order to deploy like streamlined, hardened data nodes that have as little attack surface as possible. Create a golden image of this, run a security assessment, have someone do a penetration test as for privilege escalation on those nodes. All the traditional node hardening stuff is really important in the Hadoop environment because this is basically your attack surface. The web front end in the front, of course, is also interesting, but as soon as they have the capability to submit jobs, the Linux host is your attack surface. So you want to harden that as much as possible. We usually do not recommend the use of additional kernel security frameworks in corporate environments due to like the operational issues with it. However, what we absolutely thought about was using the PAX extensions to the kernel in order to make privilege escalation a little bit more difficult. If you remember Rodrigo's keynote, it's basically some very, very good kernel hardening that makes privilege escalation close to impossible. So this is something that you should absolutely consider. The big problem here is Hadoop runs best, I would say almost exclusively if you don't have any special distributions on Red Hat-based systems, so Red Hat and CentOS. However, PAX doesn't play that nicely with Red Hat and CentOS. That's another problem that we have here. We have a cluster running. We still experience some issues with that. However, if you have the chance to have that like as a service from the like Linux department in your environment, this is definitely something you want to use in your big data environment. Also some words on isolation. Basically, all Hadoop guys tell you, oh yeah, no, Hadoop needs to be run on bare metal. Virtualization is too slow. That's just not fun. You want to have all the performance that you can get in a cluster. So something like spinning up dedicated data nodes in virtual machines for individual users or departments or anything is usually nothing your Hadoop guys will agree to. This is the approach Amazon has with their environment. Basically, you get dedicated virtual machines as data nodes. So there's no real like shared environment besides the hypervisor, but that's a different topic that you can use. Then, of course, you would think of Linux containers. Birk already touched the subject earlier when talking about like the execution container of Hadoop. So you could use Linux containers, Docker, to use another buzzword. However, the use of Linux containers does not work well together with security mode at the moment, so it's not supported. It would need some more evaluation whether the secure mode would actually need it if you have your own Docker container to run your job. However, this is still like an early beta stage, so also nothing we can recommend. Then another classical control that we're not going to spend too much time on is network isolation. Make sure that your data nodes are isolated, that as many of the network daemons are isolated from your overall network. However, if someone can submit jobs, those jobs have network capabilities. So make sure that your internal data node network is also properly authenticated and hardened, because there's no such thing as a network boundary when people can execute code on the inside by design. This is a basic control that you should have in place, but don't rely on it. So another thing that also like struck us rather late is we talk to people. So who is developing your jobs that are being run in the environments? Yeah, of course, the development is only taking place in-house. And then there are two relevant aspects. I mean, this is a general problem that libraries are pulled off the internet, but this is also not Hadoop specific. This is relevant for any software development. However, a little bit later, we heard from several people, yeah, the jobs are developed in-house, but the data sets, they come from anywhere, basically. So your jobs that you run within your Hadoop environment, they might process data that is coming from somewhere else. And I think we can break that down again to like traditional security development life cycles. If you process untrusted data, make sure you have a secure job development guideline. That also tells people, oh, if you develop a job, that's just another application. So our SDLC applies, or whatever you have in-house. People will tell you, yeah, but our SDL, that's for web applications. input validation is a generic concept that also needs to be applied for the jobs. So make sure if you process untrusted data, have a secure job development guideline.
Yeah, and there's something to add. People actually tend to think about the cluster as a multi-tenant stuff. Like if they offer a service, many companies could use the same cluster for processing their own stuff. And just when you do this, harden your node more than you think you should, because in the end, other people can execute code on the single nodes where other important data lies on. And this is something which can be highly valuable for others.
All right, what we're still working on, I think we're close towards the end. Definitely want to look more into like the log analysis for Hadoop environments, whether we can actually derive some breakout characteristics. We want to play around more with the hardened kernel in combination with the a Hadoop environment, and then of course write some more malicious code and maybe weaponize our exploits a little bit more so we can also publish that stuff for other pen testers who are facing Hadoop environments. So I think we summarized our views on Hadoop quite well during the talk, but just as a short conclusion, I think we showed you the limits of Hadoop security that you can achieve. It can be run in a sufficiently secure way depending on your requirements. Oh, that's a great sentence, right? Can be secure enough depending on. But seriously, it depends, okay, which users do you have in your cluster, which data are you processing? But you still have the code execution in the end, and this is something that is intrinsic to this environment. This is just the idea of it. You need to accept this idea. So make sure you harden your nodes accordingly. This is your attack surface when it comes to a big data environment. Also, what is something that I think will be more relevant in the future, be aware what input data you are crunching and develop your jobs accordingly. So, thank you for your time.
Yeah, thank you very much, Matthias and Birk. Any questions? There is one over there, from the gentleman.
So a quick question. So thanks for the talk. I wasn't aware that big data environments can be broken into that easily. So one part of your talk was about monitoring, securing, and I noticed that you were focusing, if I'm not mistaken, on detecting malicious job execution after a malicious file has been uploaded, like in this case, the script. And as Matthias said, this can be difficult because most of the characteristics are similar to regular big data activities. Have you thought about detecting at file upload stage, like whether this might be easier, like on the fly file scanners and something in this direction?
Yeah, actually, we thought about it. Mainly, Hadoop offers a lot of stuff to upload, exactly these files we are doing. The problem with it though, since it's normal to upload that stuff, the only thing that can actually probably find it is some sort of intrusion detection system or whatever comes in place there. Maybe this can kill some payloads, but in the end, it's just some Python code or other code or Perl code. It can be any code basically, and it's pretty hard to detect the upload there.
And at the moment, Hadoop doesn't offer any control possibility on the jobs you upload.
Yeah.
So that's
I was just thinking whether this mechanism can be like or used in
it would be an additional component.
Upload
Yes.
security mechanism.
Okay, yeah.
And you like detect shell executor class or something. Yeah.
Lines in the Python script can be easily detectable if they will be.
This is definitely something that might be worth looking into. We thought about it, but it wasn't really feasible at the moment. But yes, good point.
Yeah.
There is another question over there, which I'm willing to classify as the last one.
Yeah, hi. I have a question because we also use, for instance, Java sandboxing. I know it's not working very well, but in browsers with JAS, so you have the security manager, wouldn't be this measure to substantially raise the bar to put, to maybe only allow jobs provided as jars and put, for instance, a security manager that blacklists certain things already, like the Java Link system and stuff like that?
Yeah, basically, there's the idea with Docker, which would be like the virtualization of it and the sandboxing feature. But one other problem lies, you can write as well the same code in Java. I didn't like Java, so I thought this is a cool other idea to write it, but malicious code or backdoor or rats can be as well written in purely Java. And that's right, you can probably disable that he has other file system access, but in the end, these jobs need the access to the data on the cluster, and this is like the value data for the attacker. So you would still have to allow the access to the file system, the HDFS file system, and this is something like the attacker in the end wants. So I don't know if there's any possibility to sandbox it more.
We actually looked into some options, also like using like seccomp on Linux to restrict the available system calls, or like some frameworks to drop capabilities of the executed process. This is also something we still want to look into. However, this is nothing that is like really supported. With the Java Security Manager, you could probably deploy like profiles for the different processes out on the systems. But I would doubt that you can restrict it enough. I mean, you know your users. As soon as they can run a certain job, they would definitely cry that the security is hindering them doing all the big data analysis.
But it would definitely harden it a bit. So it would make it harder for attackers.
It's another area, especially like I like the idea of seccomp sandboxing, at least for the syscalls. To make privilege escalation harder, but this is also something that is still on our list.
Thanks again, Matthias.
Okay. Thank you.
Okay.